Okay, hi everyone. Today we're working on solving polynomials. That's back into Algebra 1. We're going to review our quadratic formula. Hopefully you guys are good with the quadratic formula. But let's go get started. So solving... Oh, I don't know why I wrote that. Okay. So solving polynomials means if I have something like x squared equals... Well, x squared, let's try it another way. X squared minus 4 is equal to 0. We have a couple ways of solving this. One way is for us talking about factoring before. If I factor it, this is factorable. X 2 plus and minus. So what x values would make this go to 0? X values? Well, x plus 2, what would make you go to 0? And then x minus 2. When we had a rule for this, this was called the zero product property. And the idea is 0 times any number is equal to 0. 0 times any number is equal to 0. So since I'm multiplying here, if I can make any of these 0, the goal is to make that 0. Okay? So we're going to go through a review, actually several different techniques that you may use to solve for polynomials. Now, they won't always be nice. And we'll go into imaginary numbers today as well. And we'll also talk about our quadratic formula when we use quadratic formula when we can't factor. Factoring is the fastest way. Quadratic formula is a desperate hammer that works. Okay, so minus 2, x equals to negative 2. That's one of my answers. And plus 2, x equals to 2. Now, my claim now is that either x could be negative 2 or 2, and that would make x squared minus 4 equals to 0. This would make it equal to 0. And you guys can do this mentally. If I put like negative 2 squared minus 4, or 2 squared minus 4, these would both go to 0, wouldn't they? Right? So we solved it. Easy peasy. But what if it wasn't this easy? What if I wrote it and I said, no, what if it was x squared plus 4? What would make this go to 0? Now, x squared plus 4 is not factorable. And in this easy case here, well, semi-easy, we would solve it like we normally would in Algebra 1, get rid of everything else besides the x. So I'm going to get rid of the 2 and the 4. Get rid of the squared and this 4. So order of operations, we're going backwards, minusing 4 to both sides. We have x squared equals to negative 4. And then if we just do it, we take the square root of both sides, plus and minus the square root of negative 4. We're left with x is equal to plus and minus the square root of negative 4. Now, if you remember, the square root of any negative number, because we can't take a square root of a negative number, this is going to be imaginary. Now, why is it imaginary? Is because there is no answer on this line here. This line here, we're already dead in the water. Why would we be dead in the water for this line here? X squared equals to negative 4. Well, let me ask you this question. What does a square do to a number? Well, it quote unquote doubles it, right? It multiplies by itself. Not always doubling it, but it squares it. But also all negatives become positive. If I take a negative and a negative, no matter what, it always becomes positive. So when I square a negative, it becomes a positive no matter what. So why are you telling me it becomes a negative here? And the answer, it doesn't. There are no real solutions. So what happens is instead of saying that we can't do it anymore, well, it's true. There are no real answers here. We created a whole new set of math numbers, a whole new set of numbers called the imaginary numbers. And we said whenever we take a square root of negative 1, so the long way to do this is the square root of negative 4 is really the square root of negative 1 times the square root of 4. This is the long way of doing it. The square root of negative 1 is I, and the square root of 4 is 2. So we broke it up separately, so we could do the problem. So the answer rewriting is 2i. We always write imaginary numbers at the end. Okay. We also had imaginary numbers. If I square it, I squared by definition is -1. Okay, I squared by definition is -1. Okay. So this was like by definition. Okay. Why is I squared by definition -1? Coming back here, if I say -1, the square root of -1 equals to I. If I square both sides, essentially what does a square do to a square root? A square and a square root, they cancel each other out, leaving me just the -1 equals to I squared. But this is by definition, remember, because I can't use regular processes with things that don't exist. Okay, it's like cook air. What are you talking about? So my claim now is that x equals to 2i, sorry, -2i, and positive 2i are solutions for my problem up here. For our solutions for x squared plus 4 is equal to 0. Now, let's go ahead and try it. If I plug in, let's do the easy one. 2i squared plus 4, will this equal to 0? So let's square 2i. 2 times 2 is 4. I times I is I squared plus 4. I squared, we said, right here, is by definition -1. So 4 times -1 plus 4. So -4 plus 4 is equal to 0. We found a way to solve an impossible problem. How do we do that? We came up with a whole set of imaginary numbers where it comes to the square root of that imaginary number. The square root of -1 is imaginary. Okay. So to solve polynomials, sometimes there are no answers. Now, I'm going to actually graph this graph for you right here. X squared plus 4 is a parabola. 1, 2, 3, 4 spaces up. The parabola looks like this. X squared plus 4. Will this ever equal 0? Where 0 is my y value. Okay. Well, does this graph ever actually touch 0? It never does, right? And because it never does, that's why we have no real answers. There's no real solution here. Only solutions are what we call the imaginary plane. Okay, let's go to back to real numbers here. So what if I gave you something like this? 4 minus f squared, no, sorry, not 4 minus. 4f squared minus 81 is equal to 0. Okay, now how would I solve for this one? We need to get rid of the -81. We have to get rid of the 4 and then the squared. So we have to get rid of a lot of stuff here. So let's just go in reverse order of operations. Plus 81 to both sides. 4f squared is equal to 81. We're going to divide both sides by 4. F squared is equal to 81 over 4. Now the next move here would be to take the square root of both sides. And can I take a square root of 81? Yes, that's going to be 9. And take a square root of 4? Yes, that would be 2. Also, here is a thing that kids forget. If you forget to write the plus and minus, we would lose one of our answers there. Now, how do I know there's two answers? Is because we talked about this before, that if I see x squared, x cubed, and let's say x to the 4th, what this leads me to is that there are two possible roots, two possible solutions. There are 3 possible solutions. And there are 4 possible solutions. But as we demonstrated right now, that you don't always have real answers. So not only could there be real solutions, there could be imaginary solutions. So what happens is, for my first set here, we could have 2 real, I'm going to use R for real, or 2 imaginary. Okay, so just like our number problem here, or our problem here, we have 2 real solutions, or x squared could be 2 imaginary. X cubed could be 3 real solutions, or 1 real and 2 imaginary. Three real, they could all be real solutions. And let me give you an example here. They could look like a graph that looks like this, where it has 1, has 1, 2, 3 real solutions. Or it could be a graph that only has 1 real solution. And the other 2 have to be imaginary. And then our last one here, this could have a couple of different possibilities. There could be 4 real solutions. It could be 2 real and then 2 imaginary. Or it could be all 4 imaginary. Now, one thing I want to say is that imaginary answers come in always sets of 2. It's always a plus minus version. It's always a set of 2. And the reason why it's always a set of 2 is because you're taking the square root of something that doesn't work. In this case, a 4th root. But it can come into, and let me go ahead and show you the drawings here. A graph could be 1, 2, 3, 4. Take a look at it. It goes to the graph 4 times. It could be 1, 2 only. Take a look, there's only 2 here, only 2 roots. And the last one, it could be just really high. 1, 2. Right, it could never touch the graph. Let me go ahead and show you guys that with the red. It touches at 1, 2, 3, 4. This is only 2, and this is none at all. So our answers may not always be real, but if they do come in imaginary answers, they always come in sets of 2. Okay, let me find another one. Okay, so let's go ahead and take a look at an example of one that would be imaginary. So we have x squared and here's a very popular one. It's x cubed minus, let's say, 8. Okay, we have a graph x cubed minus 8. And we're going to make this equal to 0. And this seems pretty simplistic, right? X cubed minus 8 is equal to 0. Now, if I go ahead and just solve it, x cubed minus 8 is equal to 0. We add 8 to both sides. X cubed is equal to 8, right? And you take the 0 here, and that's going to be the cube root of both sides. And that will give you x is equal to 2. And that is completely the right answer. Yes, that's right. X is equal to 2. But is that my only answer? Now the hint was that this was x cubed. So we need 3 solutions. We need 3 solutions. And we found one of them. Now, why can't you say it's 3 of the same solution? Well, unfortunately, it's not, right? So here's what I want to show you guys. There's a couple ways of solving this problem. One is first saying this. Okay, if you know that this is a difference of 2 cubes, we know this is factorable. X cubed minus 8 is factorable to become, I'm not sure you guys remember this, I'll write this on the side. A cubed minus B cubed is equal to A minus B. You guys remember how to factor cubes? A squared, B squared at the end. And we said it's going to be a plus plus, so it's going to be a plus AB. Okay, so this is something that we did for homework. This is something that we worked on for like 2 days. So since A is equal to X and B is equal to 2, we have X minus 2 in the front, leaving me X squared plus 4 in the back, right? Because 4 times 2 is 8. And in the middle is just going to be combining 2 and X together. So this will be X cubed minus 2 cubed, which is just A is X, 2, X, X, 2, X, right? Just copying down the values. Okay, and this would be squared, squared, then plus, plus, and minus. All right, so if I want to make this guy go to 0, well, for sure, that was my free answer. X minus 2. What will make this go to 0 is 2. 2 minus 2 is 0. That's a freebie. Now, the next part here, x squared plus 2x plus 4. Is this even factorable? Two numbers that multiply to become 4 is 1, 4, 2, and 2. And none of these add up to become 2. 1 plus 4, right? 1 plus 4 is 5. 2 plus 2 is 4. None of them add up to 2, so we know it's not factorable. So we have to go through our quadratic formula. And now it's time to review the quadratic formula. The quadratic formula is x equals to negative b plus and minus square root of b squared minus 4ac all over 2a. The quadratic formula is great because it solves for problems in which I could not factor, and it helps me just plug in and just not worry about it. So x equals to, let's make sure we know our a, b's, and c's are a, b, and c here. So a is equal to 1, b is equal to 2, c equals to 4. Make sure you guys are okay with those three numbers. So x equals to negative b, which is 2, plus and minus square root of 2 squared minus 4ac all over 2a. Now the quadratic formula always will work. It will always help you solve. But it is the slowest method. It is the slowest method. X equals to negative b plus and minus. Okay, so in here, I'm going to just do the math over here. It's going to be 4 minus 16. And 4 minus 16 is negative 12. Oh my goodness, don't tell me it's negative 12. Really? Is negative 12? So it's the square root of negative 12 over 2. Right? That's how I got it. 2 times 2 is 4. Right? 2 squared minus 4 times 1 times 4. In case you guys are confused where I got these numbers from. Now we have to figure out the square root here. The square root of negative 12, I'm going to take my time here. Square root of negative 12 is I square root of 12 because I want to get rid of that negative first. And then the square root of 12 is, if you don't know, I'm going to do a little box method here. Upside down division. Divide by 2 becomes 6. Divide by 2 becomes a 3. I have a pair of 2's, so we can kick that out. So it's 2i left over 3. if you don't have any pairs, that's stuck inside the square root. You need a pair to get out, and I can see I have a pair of 2's here, a pair of 2's here. That's why I can take that and throw it outside the square root. So to rewrite this mess is x equals to negative 2 plus and minus 2i square root of 3 all over 2. Now this next step you guys have to be good with. Can I divide the front and the back by 2? Can I reduce the fraction? Yes, I can. So negative 1 plus and minus I square root of 3. Now, this is my imaginary answer because there is no real second and third root. There is no real 3 solutions. It's one real solution, one real, which we said was 2, and 2 imaginary. And the 2 imaginary solutions are negative 1 plus I square root of 3, and the negative version, negative 1 minus I square root of 3. So will we always have imaginary solutions? No. But sometimes when we don't have roots shown on the graph, we will. Now, what does this graph actually look like? If you look at Desmos. Oops. The graph is simply x cubed minus 8. Oops, did I write that correctly? X cubed minus 8. So if you look at x cubed minus 8, we do have a root. Okay, so we have a root at 2, right? We said we had a root at 2. But we don't have any other roots in this whole graph. There are no other zeros. Let me make this in projector mode. There are no other zeros. So what happened? Well, the other roots are imaginary. So we only have one answer here. That's a lot of work for one problem. Yeah. Okay. So again, what happens when I can't factor? Now, there are, again, other easy problems. And if I give you an ugly problem that looks like this, 24 x squared plus 24 equals to negative 12 x squared minus 3. Okay, this isn't a trinomial. Because take a look, I have x squared and x squared. Let's move the x squares together. So plus 12x squared plus 12x squared. 36 x squared. I'm going to minus the 24 here, minus the 24, equals to a negative 27. Divide the 36. Seems like it's pretty easy so far. Now the problem is now I have to take the square root. X squared equals to negative 27 over 36. Well, let's go and take the square root. Now if I take the square root, remember, we can't take the square root of negatives. So plus and minus, also don't forget the plus and minus. So there are a lot of things going on at once. It's like you're cooking Thanksgiving dinner, a lot of things are going on. So x is equal to plus and minus. Now here's the part we have to be able to do. Take the square roots. So let's take the square root, take our time. What's the square root of negative 27 on top? And what is the square root of 36 on the bottom? Well, the square root of 36 on the bottom is pretty easy. The square root of 36 is just 6 times 6. It's just 6. But on top, we see we have a negative. So let's get rid of the negative first. So I would write the imaginary number first out. And then go back and take what's the square root of 27? 27, I can divide it by 3. Leave me 9, because 9 times 3 is 27. And then we have 3 and 3. Now remember, we're looking for square roots, so looking for pairs. We do have a pair. 3i square root of 3. Whatever is left over, we have to write on the inside of that square root. If there's multiple things, we multiply them back together again. Okay, so let's rewrite this. This is the top, and this is the bottom. So we have 3i square root of 3 over 6. I can reduce by 3 and 6, they divide out, to be I square root of 3 over 2, plus and minus. Now this answer, is that real or imaginary? Is this answer real or imaginary? The answer is imaginary, and that means there was no real root. The graph never touches the floor. We were expecting two answers. We got two answers, but they weren't the answers we were expecting. We were expecting hopefully real answers, but we got imaginary answers instead. Now let's go and take a look at what that looks like in Desmos. Let me just type out the whole thing. 24 x squared plus 24 equals negative 12 x squared minus 3. Okay. So let's look at our graph, making sure I copied that correctly. Now, if you look at our graph here, where's our graph? Where'd it go? Oh, there is no real answer, right? Oh. Nope, no real answer. There is no dot. You guys don't see a dot anywhere, do you? Because there is no actual real number that makes this a true statement. Now, our answer here, our claim is that this imaginary number is going to be true for our statement. Now, I'm actually going to plug it in. 24 x squared plus 24 is equal to negative 12 x squared minus 3. And I'm going to go ahead and prove to you that these are true answers, even though it's going to look a little ugly. But here we go. I'm going to say I square root of 3 over 2. Will that equal on the right side if I use I square root of 3 over 2? So it's 24. If I square it, this becomes, okay, let me show you what happens when you square it. I square root of 3 over 2 squared, okay? We're going to square everyone. I squared, square root of 3 squared, and 2 squared. Everyone gets squared. So that's negative 1 times 3 over 4. Again, take a look here. I squared becomes negative 1. A square root cancels out, leaving me just the 3. And a 2 squared becomes the 4. So this is negative 3 over 4 plus 24. Will that equal to negative 12? Same thing here. Since we square it, it's negative 3 over 4 minus 2. What happens is us checking it isn't actually going to be that hard, because 24 divided by 4 gives me 6. And 6 times negative 3 is negative 18 plus 24. On the right side, 12 divided by 4 is 3. 3 times 3 is 9, so that's going to be negative 9 minus 2. Uh-oh. So we have negative, uh-oh. This doesn't look right. Oh, that's a 3. And this was a negative, that becomes a positive. And that's a 3. Miscopied it, sorry. So that becomes a 6 is equal to a 6. And we are winning. Okay, maybe we're not winning, but we're not losing at least, right? Okay. So our goal is to be able to find imaginary solutions when we can, when we need them. Will we always have them? No. Maybe we might get lucky and not have imaginary solutions. Okay. Now, it's up to you guys to identify the methods that we need to find all the real solutions. So again, if you see x cubed, you're looking for 3 solutions. It could be 3 real. It could be 1 real and 2 imaginary, because the imaginaries always come in pairs. Why do they always come in pairs? Is because when I take a square root of a negative number, we always write that plus and minus version. Remember, we always write the plus and minus, and then we end up with a plus and minus I 2, because the square root of 4 is 2. So we have plus and minus 2i. We always end up with 2 versions of that. So I'm going to give you one more problem here. And the problem is going to be this one's going to be kicked up a notch, okay? Let's see. So the problem is x to the 4th minus 10x squared plus 25. And I want you guys to solve this, making this go to 0. You can see that it's x to the 4th. So we could try synthetic division if you want to try to break this up. But you might notice that this might be actually factorable already. Looking at this 25 here, 5 times 5, right? And isn't it 5 times 525 and 5 plus 5, 10? So we could rewrite this as x squared, because x squared times x squared is x to the 4th, right? X squared times x squared is x to the 4th. 5 times 5. And we'll write this minus sign in between. Because a negative 5 times negative 5 is a positive 25. We can solve these separately, but since they look like twins anyways, we'll do it once. Plus 5, plus 5. X squared is equal to 5. Then we take the square root of both sides. Square root of x squared equals to the square root of 5 plus and minus. X equals to plus and minus square root of 5. Now, you might say, Mr. Go, this is just 2 answers. But if I do the same exact steps over here, we actually just have repeating answers. And that's where we're introduced to a new word called multiplicity. And the word multiplicity refers to how many times an answer is repeated. How many times an answer is repeated. So number of repeat answers. Now if you can see here, the answer positive square root of 5. So when x is equal to square root of 5, the multiplicity is 2 because they're repeated twice. When x is equal to negative square root of 5, the multiplicity is also 2. And this will lead us to a skill about graphing. I can, for 100% certainty, since we said the roots were at square root of 5 and negative square root of 5, let me ask you just a quick question. This was x to the 4th, right? Aren't all numbers over here eventually going to be super positive? So what is a positive times a positive times a positive times a positive? Oops, let's made that an x. That means it's going to be a positive. So from the last root, we know the graph is going to go up. On the left, x to the 4th. What's a negative times a negative times a negative times a negative? That's still positive, isn't it? So we know this is going to be a positive value. Even though it's negative, it's still going to be a positive value. And what happens is we have a skill that we might touch on it on a little bit in algebra too, but it's a pre-calc skill where I can say, hey, if the multiplicity is even, if it's an even number, you bounce off the floor. You bounce off the floor. Instead of crossing, we don't cross, we're going to bounce off the floor. Boom, like a basketball. And we're going to, boom, bounce like a basketball. So what happens is I just graph this graph without using a graphing calculator. I found the roots, and we were able to figure out approximately what this graph would look like using this idea of multiplicity. Okay. So that's for another story, but you guys are going to be tasked today with solving by solving polynomial, okay? Now, let me give you one more. If I say, again, if I wrote x cubed equals to -8, you could go ahead and cube both sides. If I cube both sides, we did this already, okay? You end up with x is 2 times 2 times 2, negative, negative, negative. They're all negative, right? It's going to be -2, right? But isn't that my only solution? Not your only solution. And this is why the SATs can be tricky, because they give you what they seem like an obvious solution, but that isn't the only solution. And if the question says state all real solutions, yeah, this is my only real solution. But if they state the word all solutions, they want real and complex, which is what we're talking about imaginary. Okay, so just to do this problem again, we would rewrite it as x cubed minus becomes a +8 equals to 0. You would factor the problem because this is a difference of cubes. So it's going to be x plus 2 because a and b, sorry, that's a b. And it's going to be x squared 4 plus 2x a squared a b b squared. And then you would have to then use quadratic formula to then solve it. Now, I would highly recommend you practice this. If I'm looking on your test for work, I'm looking for stuff like this. How do you get the imaginary numbers without actually doing the quadratic formula? X equals to negative b plus and minus square root of b squared minus 4ac, 4ac all over 2a. If you see here, I skipped the first term, but you could also skip the last part. You could say 4ac. Couldn't you just do that in your head? 4 times 1 times 4 to save you some time. 16 all over 2a, which is 2. Negative 2 plus and minus the square root of negative 12. Now, what's the square root of negative 12? 12 is, first we know it's imaginary, and 12 is, the numbers are 2 times 2 times 3. To write it nicely, I would write it 2, 6, 2, 3. Square roots take out pairs. I have a pair of numbers, 2's. It's I, 2i, left over 3. What's left over goes inside the square root. So it's negative 2 plus and minus 2i over, square root of 3 over 2. We simplify by dividing both sides by 2. 1 plus and minus I square root of 3. And that's how we end up with our two separate imaginary answers. So our actual answers are going to be x is equal to negative 2, negative 1 plus I square root of 3, and negative 1 minus I square root of 3.